All right, hello. That sounds good. So I'm here to talk about how API developers are doing everything wrong all the time. One of my favorite topics. Uh, so we're here to talk about a couple of things. Firstly, who knows what this is? What are you looking at right now? Flags, sure, but specifically, what is this technology that we're using by grouping all these images together? You. Sprites, exactly, image sprites. The year was 2004. HTTP 1 was very slow. The technology of image sprites was a new fandangled way to, I shouldn't use words that don't exist in English, let alone French. It was a lovely new way to make images load quicker. Basically, you would mush all of your images into one image, and then use CSS to like jimmy it all around to make this one, you can see the three images down there, and you're literally using CSS to move the one image around awkwardly. This was really popular in like Super Nintendo days, like Sega Mega Drive days. They still use it in games today, but we don't use it in the internet anymore. And the way that it used to work, traditionally, you would have a web page that included images. Fancy that. But the new modern way of image sprites was to mush it all in, load one thing. Now, looking at this, which do you think is quicker? 3 web requests or 1 web request? One is better, right? Surely one is better. We did this with images. We did this with CSS. We combined everything into one massive CSS. Instead of having some CSS for the ticket booking process and some CSS for the managing profiles page, you would shove everything into application CSS. And even if you didn't plan on going to either of those 2 pages, you can sit there and wait for that CSS to load before you can see anything. Have fun with the internet, isn't that nice? We did that with JavaScript as well. We did it with everything. We mushed everything into one app.js, and nothing would work until it had all loaded, regardless of whether you wanted to use those pages or not. Brilliant. The internet's fantastic. So, seeing as all of these different types of asset are basically the same, I'll focus on image sprites for a bit because it's visually a little bit more useful to talk about. So what's the problem with image sprites? Why aren't they fantastic? Well, what if you just want that one image? You have to wait for all of that whole everything to download before you can see this one tiny little flag, and that one tiny little flag probably would have loaded quite quickly. What if that one image changed? You have to throw out the entire image sprite and everyone has to download it again, right? That's silly. What if 90% of clients want to use 10 of these image sprites? You have to wait for the entire thing, even if everyone only wants those 10. So immediately this starts to look a little bit stupid, actually. And a mere 10 years later, HTTP had covered that. We'd fixed that. HTTP 2 saved us from this hell of using image sprites for everything. And for at least a decade, the advice has been, don't do that, just make multiple requests. Making multiple, smaller, targeted requests is quicker, actually. And the world of front-end developers figured that out literally 10 years ago. The same for JavaScript and CSS. These days, it's got a new name. It's called code splitting, and that just means doing the thing we did when I was 12. So we've come full circle in 23 years, or that's not maths. I'm quite old, surprisingly. I don't look it. But we're calling it something else now. And so everyone's gone back to doing the old thing, apart from API developers. We haven't changed. We still think we're working with HTTP 1. It's silly. How often have you seen a web request, a JSON response that looks like this, right? You're just calling up the user, and you've got all of their PII, which you might not want to share in every place. You've got a bunch of profile data with a massive diatribe of a biography and everything else. You've got their locale, where they are, you've got the time zone, and then you start getting into silly stuff. You've got this last login date, which changes every time, so there's absolutely no chance you're going to cache this endpoint ever, because that's going to change every single time. So you've made that useless. Well done. And then you've got all this really silly stuff. I used to work at WeWork. You may have heard of them, not doing so well. Not my fault. I left before then. I blame other people. But buildings was huge. We had these assumptions like no company will ever have more than like 50 people. and those people will be in one building. And then over time, those assumptions changed, and Facebook and Amazon moved in, and they had 8,000 people, and they were allowed in all the buildings around the world. So just trying to load up the user information, literally trying to work out if you should show them English or French, you would then load up this entire like megabyte of JSON, and you would completely crash the entire company because that JSON filled out so much, and it had n+1 queries that not only hit the database 12 times per building and per floor, but they had to go off to like other APIs to fulfill that information. And so what we've got here is the CSS combination, the image sprite of JSON. I call this JSON combination. And this has been happening based on the idea that we think that making multiple requests is bad because some of us started development in HTTP 1.0 times, and we've continued it through HTTP 2, and we've kept doing it through HTTP 3. It's really silly. We're putting half the database into the response every single time. And so when we do something like /usersfill and we load up all that information, we might as well just call that app.json. We might as well just call it app.zip, to be honest, and download an SQL file of the entire database, because that's what people do. Instead, what you could be doing is reversing back, much like the CSS, image, and JavaScript type folks are doing, and split things onto multiple URLs. Because these multiple URLs can have different cacheability, and therefore you are letting people download the information that they want and not forcing them to wait for everything just so they can do a thing. This is one of the major changes I made at WeWork to stop it from crashing literally every day. If you wanted to find out the locale, you can go and hit fill locale. If you want to find out the buildings I'm allowed access to, you could go to buildings and ask about my user. That just makes sense, right? And so a more visual example here, we've got an invoice, and it seems small and silly because there's only so much space on a screen. But if you have an invoice, think about mixing different cacheabilities. Instead of loading everything related to the invoice into the invoice response to avoid making multiple requests, you could split that out onto multiple URLs. You could put the customer information on a customer URL, because honestly, that's probably not going to change. How often do your customers change the name of their company, right? That could be cached for a month and no one would really care. The invoice information actually probably won't change at all. That should probably be immutable, and just stay the same. And then payments, multiple payment attempts could be made and fail over time. And if you wanted to look at that information, you could then look at that. Thinking about the user interface, you would probably actually have a user interface that said view payments. And then when you click that, then you make that call. So you might not need to call that information unless you actually want to. Something else. Anyone recognize this wonderful gentleman over here? He's one of our greatest political leaders right now, and part of the reason I'm trying to move to the Netherlands. There's many things that we do apart from combination that the rest of the web have figured out quite nicely, and one of those things is streaming. So when you load up an image, it streams. You start to get some information, and as more information comes down, it presents more information. You notice there's a nice blur up effect as well. People used to use image sprites to make a blur up effect. You would make 3 versions of the image, and then you would present them all. You'd literally move different images around to create a blur up effect. But now web optimized images do that for you, right? So again, the front end world has moved on, but we're still not doing that. Not only do we vomit a giant amount of JSON into a single response, but it means that all of our clients are waiting for that entire JSON to load up before they can do anything. When that's a single response, a single resource, you might be able to split that out across multiple URLs. But if it's a collection, you might actually need to stream that. And JSON streaming, which is something I've been writing about for Bump, and it's something that OpenAPI 3.2 now supports, using formats like JSON lines, JSON, ND-JSON, JSON sequence, there's a bunch of them. They're all basically the same. You can literally just stream multiple JSON objects where each line is its own JSON object. And so you can stream loads and loads and loads of data all at once. Now, this is using HTTP, which formats it as on multiple lines, but it's on one line. But you can just stream that data, which works really well. And I actually used that for my reforestation charity. We had like 20,000 trees we're trying to show on a page, and the whole server would just crash. It couldn't handle loading it all. And even when it did, you'd be waiting for ages, and then you would get all of it just vomited at the browser, and the browser would go, oh my God, I can't handle all of that. That's a lot of JSON to handle, and it would freeze the page. But this just incrementally puts a few more bits in, and it can actually, pass that quite well. And combining these things, so I've mentioned that those URLs can be more cacheable. You can make fewer requests by splitting up your resources, but you can also add caching to streams. And that makes me really happy, because literally streaming that data the first time is much quicker, because the server doesn't have to spend ages going, oh, I better grab all this data and I better turn all of that into JSON. It just kind of sends out a little bit over time and you don't run out of memory. That's really helpful. But the second time someone calls that, whether it's network cached or browser cached, possibly both, it just goes, I've already got that. I don't need to make the request a second time. So as always, people spend a huge amount of time trying to work out how to make their APIs handle unnecessary requests as quick as possible, and they throw loads and loads and loads of servers at it so that it can handle all of these unnecessary requests as quickly as possible, and you're just burning data center compute, you're burning credits, you're wasting a lot of time and money answering completely unnecessary traffic when you could just not. And so the combination of streaming and caching for large data sets is absolutely amazing, and something we've written about on the Bump blog. Go check that out. I have no idea how I'm doing on time. I'm just cracking on. But basically, doing all these things, literally splitting up your resources into kind of more targeted, smaller endpoints means that clients can start work earlier. Instead of combining like your feed of data and then some like secondary data and some third data, like I've seen a lot of times at WeWork, they used to do it all the time, you're just waiting for like some third-party API to tell you how many meeting room credits you had left would crash the entire feed that you were trying to look at, because everything was mushed into one response. You can split that up, and then if that service is down, you don't see that thing, but you can totally work with everything that's still up. So letting clients have a say in this process by making requests to things they want and not forcing them to download everything they don't want is much quicker. It gives them the flexibility. They don't have to wait for things they don't need. It makes everything more cacheable. And again, just not making requests is good for you. It's good for your client. And it makes everything a lot cheaper. Fewer servers can handle less traffic. And you might have one Fastly or Varnish server kind of replacing 10 different application servers. And that's a cheap switch. And all of that makes the planet a lot happier, because one of the things I do in green tech is help people reduce their carbon footprint, and running loads and loads of servers because you've built a really lazy system is not the best way to reduce your carbon footprint. So on that note, I think I might have smashed through in about 6 minutes. I've lost track of time, but does anyone have questions on that? Thank you.
Yeah, you can keep it.
Ah, cool.
So we can. Does anyone have some questions?
It's true that not many people uses HTTP3. How can we convince people to use it?
So something like 97% of browsers already support it. Curl supports it. Most of your clients that you work with already support it. When you're saying like, how do people use it? Like, what do you mean?
How to convince people to use it? Because to convince developers to handle HTTP3. Yeah.
Yeah, I think most of it is like, it's already there. Like most people, when you deploy your API, you build the code, you build it Ruby, Go, whatever you write it in, you just build that, and then it ends up getting put behind various API gateways and service meshes and Cloudflare or whatever. They've already enabled HTTP3 for you. You don't change your application code to work with HTTP3. It just is there as part of the network. And so, yes, if you are using something like Puma, like the Ruby specific server, that might not support it, but then usually the thing you deploy it behind will. So the closer you can get to the application code, the better that is to work with. But generally it's just kind of there. Most of what you need to do to change your application to benefit from it is to stop mushing everything into one. Like, you make your serializers smaller. Instead of having the user profile that has everything to do with users, you just have a few different endpoints that do different things. And then If you don't have HTTP3 enabled in your network, that will be slightly slower, but it's probably still using HTTP2, which is very quick. So mostly it's just trusting the network to do its thing, because I feel like the old way of doing things was the network doesn't do this very well. We can only make 6 requests from the browser to the API at any given time, so panic. But now it can handle something like 64,000 requests at the same time. Literally, all of those parallel requests will be quicker than the one slow request that's happening. So mostly it's just like, trust the network. It knows what it's doing.
Thanks. Okay. If you want to ask in French, we can. He can translate.
I have a comment and a question. First comment, yes, I know WeWork, and I was in a company, we went from 30 to 60, and we went to WeWork, and it was not adapted at all. Yes, we are under basement, it was not a good place, there were a lot of tubes, a lot of noise, and we saw that WeWork was not working for a company that are more than 4 people.
Yeah.
Yes, I confirm that. So about the question, I did not know also this feature about streaming using the API. So I don't know if it makes sense, but could it replace WebSockets, something like that? You can use it like that?
Absolutely, yes. So one of the things people get excited about with GraphQL, for example, is that it has subscriptions, and streaming is one of the kind of underlying mechanisms that uses. So REST APIs, they can do the same subscriptions logic. When you have a WebSocket in a REST API, you're kind of accepting a post, and then usually you kind of give someone a URL and say connect to that socket and you'll find out stuff later. So in the exact same way, instead of having like a second bit of technology that you then have to document separately and try and merge those doc tools together that might not, both work together, you would just give them a URL to a like events URL, or you could literally push those events into the same response. So instead of a post giving a 201 accepted and then giving you no information, it could post a series of streamed responses. There's a format for this. So the example I used was kind of streamed data, which is just JSON, but a different line of JSON on every line. There's another one called server sent events, where it's kind of very like RPC, but in the response. So it will say like event and then the name of an event. So credit card checked, and then some data with it, and that could be a JSON blob. And it will say this card has been checked at this time, and then another event could come through and it'd be credit card has been approved. And so you can throw all of those updates into the client interface and keep on sending those events, and it's purely done with HTTP instead of WebSockets or even more complicated webhooks that you have to route back to use somehow. You just do that with HTTP. Yeah.
Okay. Thank you.
Thanks a lot, Phil. If you have more questions, you can have a very great discussion with Phil at the end of this talk. Thanks.
Cool. Thank you.